Welcome to Learning Outcome 4. This is the final one. We do understanding calculus and relevant United problem. So we're going to look at how to demonstrate problem solving using differentiation. So the first thing you must do basically is that you have to know tangent. What is the gradient of a curve? At a given point, gradient of a curve is defined as the gradient of the tangent to a curve at that point. Gradient of the tangent to a curve at a particular point. So a tangent touches what? The curve, but does not cut the curve. So let's look at examples now. You can see clearly here that the tangent is that's a tangent now. The second one you see here is not a tangent because it's crossing at this point here, but it's in between the curve. But the last one does not touch the curve at all. So that one can also not be classified as a tangent. The second one is a tangent at that point, but intersects at the other point. Tangent at that point, and actually what intersects at the other point. So let's look at the first one. So the diagram shows a curve. So let's look at how to find the gradient of a curve at a particular point. How to find the gradient of a curve at a particular point. So you have to do this. So you have to do the y, the x. You can actually differentiate. You can differentiate that. So so when you look at it now, to find the gradient, you can pick this point and you pick the other points. The coordinates of the point here is 3, 4. And the coordinate here is what? 2, 1. So what's different between the y? So it's about 4 minus 1, 3 minus 2. That gives you 3 over 1. That gives you 3. That's actually, like, you can see that one is that is 3. So in this example, you can see clearly that they used 6 and 2. You still gonna get the same thing no matter the coordinate you actually use. So how can you differentiate a simple algebraic function? How can you differentiate a simple algebraic functions? So we want to look at it. So if we differentiate something like this, 5x cubed. So I'm just trying to use a whiteboard for that. If you say 5x cubed, the formula is this. The formula is this. If you have a function like this, a x to the power of n. So y equals to that. That means that the y, the x will be equal to, you move this one, n, a, x, n minus 1. That's how to differentiate the function. So a typical example of that is this. If you have 5x cubed, you will move the 3. So it's going to be 3 times 5x to the power of 2 minus, to the power of 3 minus 1. So that gives you 15x squared. That gives you what? 15 what? X squared. So another function is this. If you have to differentiate this, 5x to the power of 4. So it's going to be what, 5? It's going to be 5 times 4 x to the power of 4 minus 1. That gives you 20 x to the power of 3. You see, that gives you what, 20 x to the power of 3. X to the power of 3. So I'll give you a few questions to do. You can pause the video and actually do those questions. So number 1, then pause the video, then you can actually check back the answer. Number 1, do 3 x to the power of 4. Number 2, 10 x to the power of 5. Number 3, 5 x to the power of 5. So you can pause the video and actually check out on the answers later. So this one gives you 3 times, you bring the 4 down, x to 4 minus 1. So that gives you 12 x cubed. While this one is 5 times 10 to the power of 3 to the power of 5 minus 1. That gives you what, 50 to the power of 4, actually power of 4. While this one gives you what, 5 times 5 x to the power of 5 minus 1. That gives you 25 x to the power of 4. So if you get it right, you can actually move on to the next step. So you can also be given something like this, where you have y equals to 5x to the power of 4 plus 3x cubed plus 4x squared plus 2x plus 5. So when you're given that, you can also do the y dx equals to, that gives you what, 20x cubed plus 9x squared plus 8x plus 2. That is what you actually want to give you. So you do this one too. You see this 6x minus 5. This one is what? 4x cubed. 4x cubed differentiation. So teach us to differentiate a square root function. So if you have root x from indices, it means what? X to the power of half. So when you have to differentiate this, it's not going to be 1 over 2 x 1 over 2 minus 1. So that gives you 1 over 2 x to the power of 1 over 2. So this 1 over 2, inverse of x to the power of 1 over 2 is going to be the square root of 1 over square root of x. So it's going to give you 1 over the square root of x. Put this 1 over 2, but that gives you 1 over 2 root x. That's how they got that one. So how can you differentiate 4 over x to? When you say 4 over x, it means that you can write 4 over x to be 4 x to the power of minus 1. 4 x to the power of minus 1. So from there, it's going to give you minus 1 times 4 times x to the power of minus 2. So that gives you minus 4 x to the power of minus 2. So it's good with minus 1 over 4 x squared. So it's gonna be just this one. It's gonna be minus 4 times 1 over x squared. That gives you minus 4 over x squared. So you can see other functions. You just look at the function example, then you see how they actually would go about it. So let's look at turning points. Let's look at the turning points. So let's look at this one. So how to solve stationary points. So there are things you need to know. You need to find the first. There's some steps you need to take. You need to find the first derivative. You need to solve that the derivative equals to 0. Then substitute those values of x coordinates into the f of x to find the corresponding what? Y coordinates. That's the 3 steps you have to take. So in case you want to identify it too in the graph, so this is the local minimum, this is the local and point of what? Inflection. Point of inflection is always the one between, when it changes, not reflection, when it also changes around, between the local maximum and the local minimum. Why this one, when you stop increasing, when it's largely what? Horizontal, that is when you know that the gradient is 0. So let's look at like a few, you can see this is minimum, and that's what? That's the maximum. How do you know minimum? Minimum is when you know that the coefficient of x squared is actually what? Less than is greater than 0, while the coefficient of x squared is less than 0 for the maximum. So let's look at few examples now to understand this more clearly. The note will be available. So derivative, then the first thing you have to do basically is that find the first derivative, solve the equals to 0, then put the x coordinate back into what? Into f of x to find the corresponding what? Y coordinate. Then for each point, calculate what? Calculate the value of f of x a bit to the left and the right of the stationary points. So are they both same derivative? If it's yes, has a point of reflection. If it's no, so this one to the left and that one to the right. So let's look at a typical example for it now to make it a lot clearer. So find the stationary point. Find the stationary point of this. So it's hard to expand it for what is s cubed minus times 3x squared. That gives you 3x to the power 5 minus 220s cubed. So you put that one this thing. So when you differentiate it, I told you before, 5 times 3 is 15. Then there's going to be 4 left there. That's the first derivative. Equate it to 0. So it's going to be this. Then you can now solve it. That is so x is going to be equal to 0. S equal to minus 2. So 2, those are 3 points. So when x equals to 0, what is y? Y will be equal to 0 too. So put it back into that equation. When x equals to minus 2, y is going to be equal to 64. And when x equals to y equals to what? Minus 64. The stationary points are this. The stationary points. And that's so if you want to actually what start with the other ones too. You want to find out the local minimum and the local what? Maximum. So start with method B. So from there, you can just look at this one. You do the second derivative. So when you do second derivative, it's like what? You are differentiating it the second time. So the other one was we stopped at 15x squared. Just put it there, 15 x to the power of 4 minus 60 minus 60 x squared equals to 0. So that one gives you what? 60 x cubed minus 120 x. So minus 120 minus actually what? 120 x. Since we know the stationary points already, we know it's going to be what? S is minus 2, S is 0, and x is what? 2. You put minus 2 there, and you see what you get is what? You get minus 240, which is less than 0. So that's what this was to test second this thing. So to test the second derivative at stationary points. For f equals to 0, you get what? 0 there too. 2, you get what? 240. That means that this one, the first one, minus 264 is going to be the local what? Maximum. While minus 2 minus 64 is going to be the local what? Local minimum. How do you know that? Because of what? Because it's actually what? It's less than, this one is less than 0. The one with, s equals minus 2 is actually what? Less than 0. So you know that it's going to be what? It's going to be on the maximum side, while that one is going to be on the minimum side. So don't forget, if you scroll back, you can see clearly that this is what? Minimum, that is the maximum. Let's get out to how to differentiate trigonometric functions. So if you say that y equals to sine kx. That means that the y ds is going to be equal to what? K cos kx. So let's get one example. Now, if you say y equals to sine 5x, then you now do the y dx equals to 5 cos 5x. That is it. It's going to be what? 5 cos 5x. So if you have, if the Ascentis is a y equals to 7, there's a y equals to 7 cos, y equals to 7 sine, sine 3x. So that gives you the y dx will be equal to 21 cos 3x. That's it. It's 21 cos 3x. That's this. Y equals to minus 7. So when you want to differentiate cos back into sine, it's going to be what? Negative sign. So it's go with negative sine 7x. So you see, it's negative sine 7x. So so if you have functions like these two, like y equals to 1 over 2 cos 10x. So that gives you the y dx equals to 10 equals to minus 10 times 1 over 2 sine 10x. So minus 1 over 2, minus 10 times minus 1 over 2, that gives you minus 5. So it's good with minus 5 sine 10x. So the final one too, derivative of tan is this. The derivative of tan is y equals to tan, if y equals to tan kx, y equals to tan 5x. So the y dx will be equal to 5 6 squared 5x. So that's actually what how to find the derivative of that. So it's very clear. So this is the final part. So look at applications and how to actually what one would differentiate so that a velocity v is this. Find the acceleration. So this velocity now in this. Now so I find the acceleration. So acceleration is what? When you differentiate velocity, that's what? Acceleration. So that gives you what? 3t squared minus 4t, sorry, minus 8t plus 3. So that's the acceleration. That one is going to be what? In meter per second squared. distance is this. The distance is if you have distance to be as equals to like 4t cube minus 5t squared plus 3t. So that gives you what? 12t squared minus 10t plus 3. That is what? That is going to be the velocity. So when you differentiate distance, it gives you velocity. When you differentiate velocity, it gives you what? Acceleration. So it's just very easy on that part. So if I actually what listening, we're gonna like get the assignments out to you so that you can be able to actually what that we address all of them. So just make sure that you actually complete at the time and submit it to what to the school. It's very important. So if you have any questions about the assignment, just let me know. I will actually what attend to you. All right, thank you. Think I will see you again. I'll be looking forward for your assignment. So if you don't mind, just let me know. If you have any questions, I will happily respond to you. Thank you.